Hi, this video is about acceleration in physics. Let's start with the story. One day I was driving my fancy sports car down the street and I pulled up next to you in your minivan at a stop sign. And just to have a little bit of fun, I wanted to challenge you to a race. But I wanted to make things a little bit fair, so I said, you are not allowed to go over the speed limit in this race. In this case, the speed limit on this road was 30 miles per hour. Well, you in your minivan think to yourself, well, my minivan can go 30 miles per hour. I was just going 30 miles per hour before. So it seems like, both cars are able to reach a speed of 30 miles per hour. So does that mean that the race would end in a tie, both of them going 30 miles per hour at the finish line? Well, the difference is one car, mine, can get to 30 miles per hour much quicker than your car. It takes a long time for a minivan to build up enough speed to get up to 30 miles per hour, whereas mine can just instantly almost reach 30 miles per hour. So I would win the race even if both of us end up going 30 miles per hour because I can get to 30 much quicker than you. This idea is called acceleration. So in physics, acceleration is how quickly an object's velocity changes. If you change your velocity very quickly, you have a high acceleration. If it takes you a long time to change your velocity, then your acceleration is low. The average acceleration is calculated by the change in velocity divided by the total travel time. And that's English. This is physics. So in the language of physics equations, we have acceleration is equal to the change in the velocity, delta v. It means change in velocity divided by the time. And notice that I've written a vector symbol above acceleration and velocity, and that's because acceleration is a vector quantity. So acceleration only occurs or only ever exists if the velocity actually changes. If the velocity stays the same, then you're not accelerating. So you have to change your velocity in order to accelerate. Well, how can a velocity change? There are three ways that velocity can change. It can speed up, it can slow down, or maybe a little unexpectedly, velocity can also change direction. Remember, velocity is a vector quantity. So if you change your direction while going the same speed, your velocity is also changing. So this brings to mind a story that I often hear when I think about acceleration and changing your velocity. When when I was taking physics in high school, my physics teacher used to be a driver's ed instructor, and he told the story of one time when he was in the passenger seat and he had a student driver next to him, and he turned over to the student driver. They were about to start their lesson, and he said, "Hit the accelerator." And this student driver had some physics background already, and he turned to the driver's ed instructor and he said, "Which one?" You get the joke. Which one accelerates the car? Well, there's more than one. The gas pedal does it because gas can speed the car up, but acceleration also could include slowing down the car or changing the car's direction. So all three of these are considered accelerators in a car: the gas pedal, the brakes to slow down, and the steering wheel to change directions. Now, normally when we say acceleration in everyday language, we mean speed up, but in physics, any kind of change in your velocity is an acceleration. Let's look at how to quantify this or put a number to it. So I've got an example here. Let's say in my nice sports car that I definitely have, I go from rest to 90 miles per hour in 3 seconds. Pretty realistic there. How can we quantify this acceleration? So we're going to try to break this problem down and go one step at a time here. First, identify what are the numbers that we're given here, and then we can use those numbers to put it together into the acceleration puzzle and calculate our acceleration. So our change in velocity, we went from 0 to 90, so that's a gain of 90 miles per hour. And then the time was 3 seconds, so I'm going to write that as t equals 3s per seconds. And then what is our acceleration? Using the equation we just saw, it's going to be the change in velocity over the time. It's going to be 90 miles per hour divided by 3 seconds. So what is my acceleration? It's positive 30 miles per hour per second. Now that's kind of a mouthful for the units there, but it's really just telling us how much the speed increases each second. So I increase my speed by 30 miles per hour each second. Does that make sense? So let's look at another example. Let's say after spotting the cops, I slow down from 90 miles per hour to 70 miles per hour in 2 seconds. So 90 to 70 in 2 seconds. What's the acceleration now? Well, now we have a different change in velocity. We go from 90 to 70. So to find the change in velocity, we simply subtract the final value minus the starting value. So for this case, the final value is 70 miles per hour. The initial value is 90 miles per hour. So 70 minus 90. I have changed my velocity by negative 20 miles per hour. Negative in this case because I am slowing down. And so I'm going the opposite direction here, slowing down. The time that it took is 2 seconds. So now when I put this into my acceleration equation, change in velocity over time, we have negative 20 miles per hour divided by 2 seconds. That gives me an acceleration of negative 10 miles per hour per second. So I am decreasing my velocity by 10 miles per hour each second. These units for acceleration can be a little tricky. There's lots of different possibilities because acceleration is the change in velocity over time. So many different units exist for acceleration. We just saw miles per hour per second. You can rewrite this as miles per hour per second like this. You could have kilometers per hour per minute. Let's say you're trying to track the average acceleration over a few minutes. So how much does your speed change by kilometers per hour per minute? You can do it that way. Any kind of speed and time unit are possible here. But in physics, we have standard units that we use for velocity and time. So for velocity, the standard unit is meters per second. And the standard unit for time is seconds. So that would mean the standard unit for acceleration is meters per second over seconds. Or we can rewrite that. These are the ways that it's commonly written. Meters per second per second. Or since we're dividing meters by seconds twice, we can shorten that even more and say meters per second squared. This is still dividing meters by seconds twice. So these two are the same thing. I typically write it like this just to remind myself I have a speed or velocity in the meters per second, and then I'm dividing it by seconds again for my acceleration. So that's called meters per second per second. So these are the two units that we're going to be seeing the most when we deal with acceleration. And we'll do some more practice to try to make this make more sense. Well, that's all I've got for you in this video. Remember, everything you have is a gift.